Welcome back to section 1-4A. So this section I'm splitting in half, okay? So we're going to take 2 days on section 1-4. So both of them are going to be about solving equations. And today our learning targets are to solve equations and solve problems by writing equations, okay? So first of all, what is an equation? And again, I know you've seen this before in both expo and geometry, but just to reiterate, an equation is a statement that two expressions are equal. To solve an equation, you want to find all values of the variable that make the statement true. To do this, use inverse operations to undo the equation. For example, use addition to undo subtraction, division to undo multiplication, all of those types of things. All right, so here's just some very basic ones just to get our feet back in the water, because I know it's been a while since you've done any of this. So here, what's being done to my x? Well, 8 is being subtracted from it. So to get to get x by itself, I'm going to add that 8 over to get it away from the x. That's kind of your ultimate goal for all these linear equations, is just get everything away from the x. Well, negative 10 plus 8. Again, hopefully you have good number sense, but if you need, you can type it in the calculator. Negative 10 plus 8 is negative 2. Here, 12 is multiplying the c. So the opposite of multiplication is division. So I'm going to divide by 12 to get it away from the c. Well, 18 divided by 12 is going to give you 1.5. The next one, x divided by 4. Well, to undo division, we're going to use multiplication. So I'm going to multiply both sides by 4 to get the x by itself. Negative 0.5 times 4 is going to give me a negative 2. Now, obviously those are the most easy examples I could give you, right? So obviously it's going to escalate from there. It's going to get harder from there. So the next one is an example of a two-step process, okay? For the two-step process, you're going to begin with addition or subtraction, taking care of that, then taking care of anything that's multiplying or dividing the variable. So here what that means is I'm going to add the 1 over first, then divide by the 2. Okay, so just remember those two-step processes, which one has to be done first. Move anything away from the y that's adding or subtracting it, then multiply or divide accordingly. Now, what happens when the variable is on both sides of the equation? So then you have to add or subtract it to combine it so it's only on one side. So now this, you actually have to do a little bit more than that, because notice this side is a little bit messy, okay? So I'm going to take care of that first. I'm going to multiply that negative 2 throughout. Negative 2 times negative 1 is a positive 2. Now, notice in this instance, my y is on both sides. So I need to combine those y's together to get this to work, okay? So what I'm going to do is I'm going to add this 2y to both sides, because that's going to cancel it off from over there. Now here, 1 plus 2 is going to give me 3. Now I'm just back to that kind of two-step process that we did previously. I need to move this negative 16 away. And then I can divide by the 3 and get that y is 6. Okay. So again, not that much harder, but you do need to remember that you can also add or subtract the variable between the sides to combine it. All right, so look at this one. This one, rather messy, right? So let's take a look at, it's usually best if you clean up both sides of the equation before you start crossing the equal sign with addition, subtraction, or anything like that. So that means distribute and combine like terms before you start messing between sides. So I'm going to distribute that 3 and I'm going to distribute the negative 2. So here, this gives me 6x minus 3. This gives me negative 6x minus 8 equals 11x, okay? So again, all I've done is distributed the 3 and distributed the negative 2. Now, combine like terms, okay? So again, right now, all I'm doing is cleaning up that left-hand side. Well, 6x minus 6x, that actually just cancels out. That leaves me with 0 there. So all I really have to worry about is the minus 3, or the negative 3 minus 8 is negative 11. So what it really boils down to is just negative 11 equals 11x. Well, I need to get the x by itself still. So divide by 11, that gives me negative 1 equals x, okay? So notice how easy it got once I started cleaning it up before I started messing between the sides. All right, now there are going to be some word problems for you, okay? So for example, flower carpets incorporate hundreds of thousands of brightly colored flowers as well as grass, tree bark, and sometimes fountains to form intricate designs and motifs. The flower carpet shown here from Grand Palace in Brussels, Belgium, has a perimeter of 200 meters. What are the dimensions of the flower carpet? So first off, I'm noticing a vocabulary term here, perimeter. Something that I'm guessing you, again, became very familiar with back in geometry. So if I'm looking for a perimeter, hopefully you remember a perimeter is the distance around an object, okay? You add up all the sides of the shape. So notice here, this length going this way is x. This length going this way is 3x. So if I'm finding the perimeter, if I go around, that's going to be, I have a side length of x, then a 3x, another x, then another 3x. That incorporates all 4 sides of this rectangle, okay? And what does it add up to? Well, it says it adds up to 200. The perimeter is 200. So now, once again, here's a good opportunity. Let's clean up this side of my equation. So 1x plus 3x plus 1x plus 3x, well, 1 plus 3 plus 1 plus 3 gives me 8. So I have 8x equals 200. And now, obviously, I'm going to divide by the 8 to get the x by itself. And that gives me 25. So to really answer the question though, the question is what are the dimensions, okay? Well, one dimension, and let's see here, is it meters? So one dimension is 25 meters. Well, the other side is 3 times that length. So the other side is going to be 75 meters. So in this case, the answer isn't just finding x, the answer is finding the full dimensions of that rug, okay, or flower carpet, I should say. All right. Now, here is getting at some of the 2 special cases, okay? So when we're solving equations, usually we get one answer, okay? We get the number that x equals or y equals or whatever variable we're talking about. But sometimes there are 2 special cases. This happens when the variable cancels off, okay? So when the variable cancels off, what ends up happening is a situation of infinitely many solutions or no solution, okay? So let me give you examples of what that looks like, okay? So here, let's clean up both of these sides, okay? So on this side, I see 7 or sorry, I see 11 minus 7. And on this side, I see 3x plus 5. So notice I have 3x on both sides of my equation, okay? So I could subtract 3x off in attempts of bringing it together, but instead of bringing it together, both in fact disappear, okay? I lose my variable altogether. So when you lose your variable altogether, in this case, I'm left with a nonsense statement. Obviously, 4 cannot equal 5, okay? So when you're left with nonsense, that's going to be a no solution case, okay? Now, let's look at the other problem, okay? So here, when I clean up this side, 6x minus 2x, oh, that leaves me with 4x. Here, I see 4 plus 1. So this time, again, I have the same x's on both sides. So when I go to subtract off the 4x, instead of combining, it cancels them off. And this time I'm left with a true statement, okay? 5 will always equal 5. So what that's telling me is it doesn't matter what x was. Anything x was is going to lead to a true statement, okay? So what that means is x could be anything. I have infinitely many solutions. And if you just write IMS, I'll know what that means, okay? So that's how you can summarize this, or not summarize, but abbreviate it. If you don't want to write infinitely many solutions, just IMS, I'll know what you mean. All right, so again, those just kind of represent the two special situations that can happen if your variable disappears altogether. So once again, thank you for joining me for this. That is going to wrap up today's notes. Make sure that you go back, write that summary for me so I can see that you've contemplated and thought about what we've talked about. Again, it can be the highlights of what you learned, anything new that you learned, anything that you knew from geometry that I thought was interesting, it came back up again, or even questions you still have, you want to make sure you ask me. Anything, write down in that summary and then just come back ready to do our practice work tomorrow.